Hello and welcome to another tutorial. This time we're going to build an Overwatch style or fan art building generator. As you can see here, this is a scene that I built using this tool. Every building is generated and I will show you how this is built. Before I go any further, recently we had over more than 20,000 subscribers. So thank you so much for the support and seeing that everyone really likes those videos and that they are helpful to everyone. Definitely feel free to like and subscribe if you want to see more tutorials and more information about how things are built in Houdini or how we can build things in games. Let me know. And today I'm going to continue on with the building tool. There are some other tools that I've used here in the scene, which I might talk about later on. But for now, let's immediately jump into this. The idea is that we will basically make boxes and stack these boxes on top of each other and deform them and add models on them. So as you can see in the more finished version of this tool, we will basically, as I said, we will create a box, add some details like windows, borders, pillars, and that will be one floor. So we'll have a special menu, which is called a multi-parameter, and we can add more boxes to this or floors to this. So we can just add more of them, and you can see we will just generate them, and you can like play around with like different heights and sizes and so on. So you can change those things based on what you want to see and so on. Or you can create like a modular assets, like maybe I only need this version and so on. So this is like roughly what I had for this tool. So this is what we're going to build, and I will show you some of the ideas and approaches that I used here. So to start off, I'm just going to make a box shape. So this will be our floor. Simple box, nothing too special. We can just leave the default values. What we also need is that for each floor, we will place a box. So that basically means is that we're going to do a loop. So we're going to do big loop, so for loop, and we're going to do a for each number. So these numbers basically means the amount of floors. So in our end loop here, the end node, we will have a certain iteration. So by default, it's 10. So we will do a certain amount of floors. So let's say this is already 10 floors. So if I place my box in here, like so, we are basically looping this box 10 times, but we are keeping the same box. So it's not really doing anything. So let's already start out by making a digital asset, which is called an HDA, and we want to wrap this up to make the multi-parameter. So I'm going to select everything, going to go to assets, asset from selection, and just name this something like Overwatch building or house, something like that. So then a menu will open here on the side. We can go here into our parameter folder, and we can drag a folder. We can rename this to floors. I'm going to rename this over here as well. So floors. And we want to set this to a different type. So we want to make a multi-parameter, and we specifically want to make a tabs. So for each new item, we will create a tab instead of like a list or scrolling list. So we want to make a tab. So we're going to press apply, and we will now see the same interface as I had before, where we can click the plus icon. So it's creating tabs, but we don't have any values yet, like floats or something else to work with. So we're going to add here a couple floats, and we just want to use X, Y, and Z. So I'm just going to speed this up a little bit. So I'm going to just X, Y, and Z, and when we press apply, we will see that there will be a hashtag included. So this hashtag is basically referencing the number that we have. So if we press this 3 times, our X is actually called X3. Or for example, here in the first iteration or the first multi-parameter is actually called X number 1. So that's good to understand that the hashtag is replaced by a number based on the slider that we have. And also importantly is we should set a default value in the channel. So let's go by 2, 1, and then 2 again. So that means we have 1 in height. So 2, 1, 2. And this is a basically setup. Let's create one floor again, and let's dive into our loop. So we want to connect that multi-parameter interface with the loop. So let's already make some more room for later. First thing to do here is we want to control the iterations. So this number should now be controlled by our loop. So channel, we want to grab our floors. This is basically the name of the folder, and this will basically now return 1. So for me, I just call it floors. So we'll basically grab this number over here. So number 1. So if I press 2, it will basically now return 2. Now, another thing, or the thing that will require a bit more work, is how can I now get that value? So we have x, y, and z, but we have this multiple times, as you can see. We have this 2 times in our case. So how can we get now the correct value? So the first thing to do is we need to get the feedback or iteration number. So we're going to go here to our node, which holds the metadata, as you can see. This has detail attribute, which is called iteration. So I would like to give access to that. So what I usually do is I would add a spare input here. And at the bottom of the node, we can now drag and drop another node. And they are now basically, as you can see, linked together. So whenever I type -1, it will basically reference to spare input here. Now getting that value might be a bit more tricky. So here I will type what we will need. So what we usually would do is we will type get channel reference. And then we would, for example, say I want to have X. So as you can see, we have here X1 and 2. So we want to automatically select those in the system based on the loop. So let's maybe break this down here on a notepad, how that would look like in the loop. So we want to get a channel, but we need to combine the name with a new iteration number. So we want to combine a string, which can be done by this expression. And then we have a part where we're going to ask the x value, for example. So x, and just don't put any numbers in there. And the number will come from the detail value -1, which means look at the spare input. And we want to specifically get iteration index 0 and then close it off. So that's the part that will basically look at the metadata and get iteration number. We also want to do +1 over here because we need to start from 1 because x1 and x2, it doesn't start at 0. And then close off this here. So this is a way on getting the values. So we want to go back to our box and I'm going to fill this over here. And this will return number 2. So to quickly recap, so we are basically getting the channel X here, but we need to get that number. And basically this piece of line, so this piece of code will basically look at the detail value of -1, which is basically spare input, which is then referencing here to the detail and iteration. So here I'm just asking get the iteration number, which is of course coming from here, iteration. So we are getting that value over here. So make sure to copy this again and paste this over here and change the X to Y and then here to Z. And that should all work. So X, Y, Z. So 1, 2, 1. So that's basically now linked. So if I would go back over here, I can now, as you can see, scale the box. Now, one currently a problem is that we basically have 2 boxes. As you can see, we have 2 different boxes, but they are just overlapping with each other. So I can create more of them and they're just stacked all on top of each other. So it's not that interesting. So now how can we get these boxes to be stacked on top of each other? And that's where I would introduce a feedback loop. So we want to get the feedback of the previous iteration or the previous generated meshes. So here in our output of the for loop, we're going to go into gathering method, and this will basically need to be set to feedback iteration. So this will now return a feedback. So we need to here get this other node. This by default will fetch input. So if we input a certain model here, it will just get that through the loop and we can use that. But in our case, we want to basically say fetch feedback. So that means that if something was already generated in a past iteration or a past loop, we want to get that. So in our case, this is box number 1. So we want to then basically use a match size node. I want to link those here as inputs. And we want to say stack on top of each other. And we can do that here by changing some values. First of all, the X and the Z can be set to none because we only care about the height for now. We want to set this to minimum and maximum. And as you can see, they're now basically stacking on top of each other. So fill this in over here. And now we have this box on top of each other. As you can see, since we are doing the gathering method on feedback with iteration, we also actually need to merge the iterations back in here, or the feedback. We need to merge this together, like so. So again, this is the data from the previous or the past loop that happened. So now I can here, as you can see, add more of the buildings or more floors, and I can play around with these values and change that. So this is a construction of a basic multi-parameter and a loop with that. So with this structure, you can already do a lot of different things and build a lot of cool tools. Now to continue, we want to, of course, make our floor or the building a bit nicer. So one of the first things I want to do is just adding a bevel on the sides here. So let's make a split of the geometry based on the normal. So we want to only get the Y here, and we want to invert this. And we have this shape now, and we want to just do a bevel here. So poly beveling, and just bevel it a little bit, like so. You can also do things like random bevel, which I have a video on. So if you are interested in that, you can watch that on the channel. That's basically what we can do with a bevel. We can fill this back again with a polyfill. If you just want to quickly fill the gaps, you can just set it to a single polygon. So we'll just fill it without creating any additional wireframes. And we also maybe want to output a patch group for later, but more on that about it. And make some more space here. And let's take this line over here. And then we have a basic shape like this. Of course, to make this even better, I'm gonna now also talk about adding different props, like how can I scatter windows, doors, and so on. How can we do that? Now, to make things a bit easier, I already pre-made some models. I made this in Houdini as well. You can make this in any software you're familiar with. These can just be very basic models, as you can see, just a basic frame for a window. Something like this is good enough for us to work with. So the idea of the tool is that you can basically take your own models, or if artists would provide additional models, we can just add that to the list and the tool will work with that. So we're not necessarily constrained with what you would make here. We are adding an option to add more and more models if the model amount would grow. So for each model, I want to create a value. So create an attribute. So here we're gonna just give this a name like ID, and this can be a integer, and this can, for example, be 0. And I want to do that for all the models. This can, for example, be my small window, and this is then, for example, called ID number 1. So later I will just merge this together, and I can still know which model is what based on the ID number. So if I ask ID number 1, it will get a window. If I ask another ID number, I get different sizes. What I'm also going to do with these models is I will basically do a Boolean between the shape and my walls or the house. And since I'm working with a bit more complicated geometry, I want to simplify this to just the bounds. And what will happen is I want to Boolean the bounds with this here. So I want to make an opening in the geometry. And I want to then basically on top place my window so it nicely fits with that new geometry. So what I want to do here is for each of these models, what we will do is we want to create a bound. So as you can see, this is the bounds node. We will just calculate the bounds. And this will then be the shape for Boolean, so to make the holes in there. And in the bounds node, it won't go over the ID number. So we created an ID number, but this is now gone. So we want to basically do a copy of the attributes. So here we want to copy that over. And what we will search for is, instead of color, look for the ID. So here, in this case, it will just be 0. I will also save the bounds in a group. So this will be the group, and this can be called bounds. So later on in the system, I will say that I only want to get the bounding of the objects, and I can just simply do that by this node, by this group. So this nodes I placed over here, I need to repeat that for each model. So if you have 10 models, you will need to paste that multiple times. So there is a nice way of copying the same logic over and over again without having to make an HDA. So in this case, it's not really useful to make like a digital asset out of this. It's not that useful. We're going to use something which is the compile block with an invoke of that. So let's make a compile block here. And we can, for example, just plug it in like this. Plug in over our lines like so. And let's do a merge like here. So in a moment, I will talk a bit more about it. So this is the setup of the compile block here. So what it will do is it will basically create a bounce around my window, and it will add the ID number to the bounce and the group to the bounce. So I want to repeat this system for each of the models, basically. So we have then the additional node, which is called the invoke compile block. I'm going to give this a yellow color quickly. And what we need to do with this is we need to now link these together so it knows what to do with it. So it will ask for a name, and it will also have to add which compile block. So we can just drag here this into it. And now we also need to give this a name just to be clear with that. So here we're going to fill in for example, the name, which can be bounce. And just to make sure it like works, we can also fill in here the name bounce. In case you would use multiple inputs and so on. So we have that over here. So the invoke is working, as you can see. So we'll create the bounce and the shape. So if I would now copy this over here, it will do the same. It will create a bounding box, and it will create here the ID number, as you can see. So it's number 1. So we will do that for these things as well. So this is my door, and we will create a bounce for this. So that's a quick, nice way of doing that. If you want more information on that, Paul Ambrosen has a really nice video as well on explaining how this invoking works to your advantage. Now, what I want to do with my balcony is I want to do a different logic with my balcony, because I don't want to subtract or boolean any geometry with the balcony, because it's just a balcony model. We don't need to cut out a hole in the wall to place the balcony. I want to just place those on top of each other. So with the balcony, I'm going to give this the same ID as my door, because I will merge these together. And for now, I'm just going to merge these together. So this is the result of the balcony. So when I place this model, I will only subtract this part, the door part, and not the balcony part. In a moment, it will make more sense when we start to combine the geometries. So let's now merge these all together. And these are basically our assets ready to go. So I have a bunch of windows, doors. So these are just some test assets to go. Now back to our system, and we have our assets, we have our wall. We need to only define the locations on how to place them. Now to do that, I'm just going to make a subnetwork where we're going to calculate everything. So just to make sure that we have some structure in our room here. So the first input of the subnetwork, or we can give this a new name, that for example says like scatter assets. So first input can be the basic cube. So it's just the basic cube without the beveling. So you don't have to calculate those differences. Then our second input can be the models. So we have an idea of how large the models are. And then also we want to here have the metadata. We can maybe call it like this. And we want to also maybe use this over here in case we need it. We have it ready to go. So let's jump into this network. So it's just the same. So a subnetwork is just the collapsing nodes together in another layer. Nothing special. It's just the same layers and nodes you can do here. So let's calculate some spaces where we can scatter assets. What I want to do is I want to just, for example, split the geometry back again by normals. And I only want to have, for example, the bottom shape. So minus y. So this is the bottom shape. Then we're going to convert this into lines. So we have just simple lines and no primitives, as you can see, just lines. Then we will do a primitive split. This will basically mean that the lines will be broken up into different primitives. So each, so as you can see, if I select them, these are all separated lines or primitives now. And with that, we can do primitive properties. And primitive properties means that we can basically do here a transformation in the scaling. So if we scale this a little bit lower, we basically now are shrinking the lines by a scaling value. So we can do something like 0.6 or maybe 0.5 or 0.4 even. So just shrinking those lines a little bit. You can define however you want this to be. I'm just going to stick to 0.5 here. There might be a fuse needed in case the lines are too small. We're just fusing them together. And since these lines are still basically flat on the ground, we want to do a match axis or match size again. And we want to plug this with our original shape. And this will make sure that our lines are now in the middle of the shape, as you can see. We place them in the middle of our building. Now we have our lines, so this will be the area where we can place our models. And what we want to do is we want to use the chain node. This is a useful node to copy models on a line. So we have also our models. If you remember, this was my second input. So the second line of the subnetwork. To do that, I'm going to just purely ask the bounds of the shape. So here we had our shapes. And we're going to say get bounds and invert that. So these are the bounds of the models. And we want to use that in our system. I also like to do an ensemble as well, because this will be packed geometry. We want to here enable create packed geometry. Basically, our geometry is now represented by points. So as you can see, I only have 3 points for each cube or each model. A couple things to do here as well is we want to do transferring of attributes. I want to get the ID number, and I also want to make sure that the pivot point is basically the same as the original one that we provided here. So if you just send it to centroid, it will just calculate the center of the box, and that's your pivot. But we want to have original. Then we plug in our models and our line, and it should just copy the shapes on the line, as you can see. We notice that they are rotated 90 degrees. So let's do a transform quickly here. So we can just transform it, I think probably like 90 degrees. Make sure it's like positive 90 degrees, like so. And this is then what we will have. So we will have 2 windows now being scattered on the building. Now in the chain node itself, there are a couple options that we might want to change. So first of all, if we look here at pattern, we want to change this to a random cycle. Instead of placing the first models, it will find based on the order you provide. So this is a bit more random way of placing them. Then we're going to go into alignment, and in the alignment, we want to disable center geometry because we want to make sure that we are consistent as possible with the placement. And we also want to fill in a spacing. So all the models are basically next to each other. But of course, if we place a window, we want to maybe have some spacing between placing the next window. So as you can see, we are just making a little bit of space over there. So that's almost ready. So we have the locations of where models could be. And we can just now use the add node to remove everything but the points. So now I have the point locations where I want to have models. And this is basically because we are packing the geometry. So if you don't do packing, you will basically have more points. So make sure you're packing geometry. So this is the location where I would like to have my window or my wall. And they are again here, they are represented here by the ID number that we created. So it's important that we have the ID number. One more thing to do here is we need to have a certain idea of the orientation. So usually I would calculate the normal in how a model should be orientated. So we want to just transfer the normal data from the walls. So let's go here to our walls. Let's do a subdivide with that. And in here, we're gonna just set the depth to 3. And we want to increase the weight here. So we're not moving or deforming this too much. We want to calculate, of course, the normals of the shape. And in this case, we want to do point normals. And we want to plug this in over here. And if we should view the normals, you can see that they're all facing outwards based on the wall. So as you can see, we have no normal information. Here we have normal information. So that's useful to have when we are copying the points there, or when we are copying models on points. And this is then the output of the model, like so. Now with this, we are ready to do a copy to points. And we're going to copy the models to the points. And of course, they will just look like this because we now need to filter on the ID number. So we're going to use the piece attribute and we're going to use ID number. And as you can see, this is more consistent with what I want. So now we want to split, of course, the bounding box. So split the bounding box. So here we're going to again ask the bounds, and these are then our models, and this is then the bounds. So we need to boolean those bounds with the wall. So here, let me grab my wall and the boolean like so. So we're booleaning the shapes, so we have room to place new models there. What we can also do is, since we don't need the geometry that we created here, we can set this to surface, and it will basically create gaps in the shape here. And we can merge, for example, our new models, like so. And you can, for example, do like a fuse if you want to merge the new models in the shape, or you can do another boolean to merge things or so on. It's up to you if you want to merge the models. So that's basically how we can do that here. So this is then my new output. So let's place it like so. So I now can create multiple floors, and there are a few things that we want to tweak, but it's already working really well, as you can see. So if you go back into our network and to our scattering system, we want to define some more values to, for example, randomize this. So every time we place a building, it's the same thing or the same models, as you can see. So in our chain node, if you go to our logic on the first tab, we have a random value where we're not using this. So what we can do again is using that metadata and use that as a random value as well. So here, add spare input. I'm going to create a null node. And we want to just link those together. And now again, these nodes are linked. So we can do the same as we did before. So we're going to ask the detail value -1 means getting the spare input, which is the metadata for the iteration. So we want to get iteration and we want to get 0. And now if we would go back, we will have now some more randomness in there. We can also, for example, do a random deletion or selection here in case we want to add an additional random step. We can, for example, here delete random points, which, as you can see, if I use this node, we can delete random points in case you want to add another layer of randomness. This could be useful to do a random deletion of some points. Now, another thing is if we look at our first floor, we are placing balconies, but I don't want to place balconies on the first floor. So we can solve this issue by adding a group here to my balcony. So if we add a group here, and we, for example, name this something like first floor not, we can then later ask this. So make sure if you're using groups to give them very obvious names or to keep a certain structure in the naming of them. So here, if I get the first floors, we want to then blast away. So here, we can just say first floor nodes, and then we can here either remove them or add them, as you can see. Of course, we want to automatically switch this. So we need to have a switch in place, a switching node. So again, we need to do the same thing to get our iteration number. So again, creating a spare input, and I'm going to link the node to get the iteration. And over here, we're going to type in again that logic that we typed a few times before. So -1 iteration index 0, and this will return the value. What we want to do is we also want to create this like an if statement where we're going to say that if this value is not equal to 1, we will basically take the one with the balcony. If this value is equal to 1, which will return 0, it will basically pick the ones without the balcony models, like so. Oh, I made a mistake here, of course, because this has to be 0, because the iteration value starts from 0. So we can see that we can now have no balconies over there. So of course, my model is not perfectly aligned because the alignment over here is not that nice. So make sure when you import models that they're also aligned nicely. It's also good to take in consideration. Another thing that I noticed here is that, of course, if you can play around with this if statements, now you can also know how to do things on, for example, the 3rd floor. So every time we reach the 3rd floor, I want to do something special. So you can actually do that by writing logic for it, by saying like, this is the 3rd floor, only do this and this and this. So you can write custom logic and IDs for each floor, basically. So now that system is in place. We might do a normal here as well. That might sometimes be needed. In our case, it's definitely needed to do a normal. Let's pick 35 degrees. So we have something that looks like this. Next step could, for example, adding pillars. So let's say we want to do a pillar on each side of the corner. So the pillar itself is not that complicated. So we're going to gather information where we want this pillar to happen. And we want to here grab some of the information by another split node. So split by normals. And we want to here grab, for example, the bottom plane, which is then -1. And on each of the points, we want to then copy a pillar on the point, so a certain pillar shape. So we can grab a box, but I'm basically going to copy our original box, which is linked to our multiparameter. And I want to remove the x and z values. So this value, we're going to just say delete channel. Here the same, delete channel. I want to fill in a custom value like 0.1 here as well. So basically our height will be the same as our building's height. So if we scale the height of our building, our pillar will basically match that as well. So if we have the pillar over here, we can also do a match size node. And this will be needed because we need to set this in the minimum and the height. The only reason for that is when I do a copy to points now. So copy to points. It will basically now just sit on the middle. So they're not rotated in a good direction. In this case, we can basically say ignore any information of orientations that we have. That might work for us. But what I usually would do is usually do like a polyframe, calculate a normal, and make sure they are aligned nicely. But in this case, it's good enough for us. Then we can basically continue here by merging this result over here. In case you don't want to have a pillars, we can build a switch node. So here switch, and we can do a null node as well. So null, like so. So we can switch the pillars on or off with certain toggles. So on, off, on, off. And we can again bring this into our system. If we go to our properties, and we would add a toggle like so, and we can call this like pillars. I'm gonna here as well. And we, of course, need to get the iteration value again if we want to make sure this is fully integrated with the multiparameter. So spare input, link the value. I'm just going to copy paste what I had here on the notepad, which is the same from the box and so on. And we're going to paste this over here. And instead of this value, we're going to type in pillars. So you can see we have, so as you can see here, we have pillar 1, 2, 3. So just type in pillars, and then we have a control of that. So if I go to my tool here, I have now the option to add pillars on each level if we want that. So we have full control of that value. You can, of course, make the pillars better if you look closely in how Overwatch does some of these pillars beveling, and how I did it as well is by using a trim sheet. So you can just use a trim sheet to fake the roundness or beveling of certain objects. So this has a benefit that your models are way more low poly. Then let's continue by adding borders. So adding some borders will make the building look better. And we can create here as well from this node, from this branch. I might do another sub network, and this is again just purely for structuring. You can do all of the nodes here in this level, but as you can see, we are keeping a quite simple structure you can follow. So here, this will then be adding the borders, so borders. So I connected here from the split nodes over here, and let's find something to calculate here. So from these shapes, so we have a border for the top of the building and then the bottom of the building or the floor. We're gonna just do a convert of the lines. And with that, we want to then do a resampling, which means that we will be able to create more points on the lines. And I'll specifically only do a resampling on segments. And if we fill in 2, we will basically create the middle point of each line. I want to get the middle point to actually make the shape look nicer. So we can go here to our attributes, and we want to output a curve U value. So curve U value means from 0 to 1 how far a certain point is in the shape. So 0.5 means it's the middle one because it's exactly in the middle of the line. So if we do a transform now, and in here, if we say add curve U, if it's equal to 0.5, 0.5, we want to then drag down this value, and we're going to make sure it's set to points. So make sure we set it to points. And this value is maybe too much, so 2.1. So you can see we can just drag it down like that. So you can make this value even more subtle. I don't think we have to do all of movement here, just so it's not that aligned anymore. So we have some shape there. To make it a bit more high poly or smoother, we can just do another resampling. So here we add more points, and we want to, for example, do like a subdivision or an interpolation. As you can see, we'll just add a bit more to that shape. Now to reduce that poly count again, we want to do a face node, and in here we can say remove inline points. So we'll only try to keep the points where the shape matters the most. So here we only have a few points. So again, we are aiming for a more low polyer type of poly count. Then we want to merge the lines back into one single line. So if I look at the primitives now, they are basically separated from each other because the convert line here will detach everything. So we want to do a poly path node, which means merging the lines. We want to enable here connect endpoints. So this will make sure that we are merging the lines again. So we only have 0 and 1 here, as you can see. And we want to do a simple sweep of that line. So here, for example, sweep of a square. So if you don't do the polypath, it will basically, as you can see, break the corners because it's not merged. With the sweep node, we can also use a more custom shape that I want to use. And I want to use a labs node for this, which is called super formula shape. So you can do all kinds of cool shapes, but I just want to have a simple rectangle shape, which I can do here. I can make a very simple rectangle. I'm going to set the values here to 0.07 and the height to 0.05. So we have a rectangle shape like that. Then I want to do a match size node. So we want to make sure the shape always aligns with the world. And I want to here in the x-axis set this to minimum. So it always, as you can see, will always be on the x-axis on 0. So this is my custom shape here for the sweep. Let's now change this to use input. And we'll basically, as you can see here, we'll basically now create a border. So now I can make my border longer by changing this value here. As you can see, like, we can extend the border in case we need to. So let's break that in over here. We might need to do a normal recalculation of the normal here, like that. And this is then basically ready to go with our setup here. So plug it in the merge node. And let's see how that looks. That looks good enough. So again, if you don't like how much we are extending the shape, you can always go back to the sweep node and change those values to make it less going outwards. And we're almost done with our building. So we have added a variety of different things. And one of the things that I still want to add is adding support structures, or at least thinking a little bit. I'm not going to go super in depth into it, but what about the fact that, let's say, building, let's maybe take two shapes. Let's say we have a shape that goes, or a building that goes this way. So maybe we want to create supporting areas or beams. And you can expand this as much as you want, but I'm going to just give you some information on how you can get started with that. So we want to create another network over here. Now to calculate supports, I want to create a new sub-network. We want to have information about our current shape, which I'm going to just take from here. And we want to also get information about the previous shape, so we can compare the two differences. So in this case, we want to compare floor number 1 and 2, so we can check the differences. So like so. And we can call this support. So that's the start of the setup. Now, what I want to do is I'm going to split here by the normals again. So split by normals. I'm going to say that I want to have the y min, which is the down facing of the current one. And I want to compare the top primitive from this version. So this was our feedback version, which is the previous version. So I want to actually have a clean, just top facing primitive. And I'm going to use here our polyfill data that we previously made. So previously I enabled here enable patch group, and I'm going to use that in our feedback. So if you enable this, make sure you're going to rerun the loop again. So we have it in the feedback. And if we now do a blast node, and in the blast node we say get patches and invert that, we now have these patch groups, as you can see it. So with that, we're gonna now only get the top one, and there is a nice trick for that. We're gonna do a sorting node, and we're gonna sort the primitives based on the y, which is the height, and we want to invert that. So primitive 0 will be always at the top. So I can just say blast everything except primitive 0. So filling in 0 primitive and inverse that. We can also see that the corners are beveled from our system. I'm just going to make a bounce of that. So I'm going to work with the most simplified geometry. So we're making things a bit easier for us to work with. Then in our bounce, we have a very flat box. We want to actually add the minimum size to 0.6. So we have basically a box. So with this information, let's do a boolean of the two shapes over here like this. So what I've now created is actually the differences in geometry between the building and our new building. So as you can see, I've created just these faces of primitives that are basically where the support needs to be. So you can use this information to do a lot of different things. I'm going to show you one example, but definitely feel free to maybe explore different types of supports and overhangs. You can do cables, you can do other kinds of structures, like additional pillars, additional supporting beams and structures. I'm going to just add a few beams to support this. So what we can do here as well with this information now is we can save out a group called AB seams, which will basically be the edge of these primitives where we had the boolean. And for this group to properly work, we probably have to set that our first input A, is actually a surface and not a fully primitive, because this is just a flat surface. Then we're going to convert this into lines. And then I would like to have the AB seams group into my lines. So what sometimes happens is when you do convert curve, it might get rid of the group. So here we have AB seams, and here we still have it, but here we have number 2, and here it's basically saying 0. So doing this node, it will delete some values. So we want to do a transfer back again of the information. So here, transfer the group, which is a edge group. So we can disable everything else. So AB seams, just override, and you can see it's already working. So we are only selecting this primitive or face or edge in this case. And now we can do a blast node. And we can blast the seams, and we can also do an invert of that. So now I have the 2 lines where I want to have a connection. So I want to connect these 2 lines to each other to create a certain support beam. So here I'm gonna do a resample. So this will create more points, as you can see. We probably want to do a polypad in case the shape gets a bit more complicated. So you're sort of like seeing this as one big shape. And after that, we want to do a poly frame. So with the poly frame, we are going to calculate the normal. So let me enable the normal view. And we want to here fill in the tangent to normal. And we're going to just go with first edge to calculate the normal. Now I'm going to use a little bit of vex or wrangle code here. So let me place a wrangle. I've not used that much in this tutorial. To make things very simple and beginner friendly. So here our normal now will be basically get a cross product. So let's use the cross product, and using that will basically rotate our vector or the normal. So we're going to use a vector, so one like so, and you can see it's now facing this direction. I actually want to have it facing in the other direction, so I can simply solve this by using -1. So we now have the normals facing the other line. As you can see, they're facing that line that I actually want to do something with. So now what I would like to do with that is I want to cast a ray with that. So we're going to use the ray casting from this to the other line. As you can see, it basically worked. So by default, if you use the ray node, it will basically get the direction of the raycast or the projection based on the normals. That's why I calculated the normal here. So if I don't calculate normals, or if I calculate them wrong, they won't do anything. So make sure they're basically facing in the direction you want. So now I have these 2 values, and I want to connect these points to each other. An easy way to do this is by enumerating the points. So here, if I just create points, enumerate them on index, so it will create a new attribute. We can merge these together. And we probably, what we want to do here, I'm going to remove any additional information and only keep the points here as well. So we only have just a bunch of points. And if I do another add node, there are a bunch of add nodes here. We're going to use the function of the add nodes where we can where we can connect polygons or points together. So here we're going to do points by group, and we're going to say by attribute now. And we want to use the index value. And it will basically connect the points based on the index value. So we created here an index value. So it will, again, just connect the points based on the same value as we have here. As you can see, we have them double. This is a nice way or an interesting way of quickly connecting some of this. Then the last thing to do here is maybe a fuse in case things are too close to each other. Maybe just fuse them together. Then we do a sweep. nodes. Just want to give them a simple shape, like a square. Oh, like square here. Make them a bit more smaller. Reduce the point count. And if we want to have less of them, we're going to go back to our resampling over here. And we want to just increase it like so. So we have less of the supports. And that's basically then our output, which is then the support beams. And we can here again plug that in over here, like so. So now we have support structures, as you can see. We have support beams. So you can play around with this and, for example, do a transform. And I can transform this like so. And I can have something like this, for example. It's not necessarily going to be like super perfect, but it will work in most cases that we built here. What is also interesting to know is when we do an array, we can also ask the distance. We'll give you an attribute distance. So what you can do is based on the distance, you can do different kind of logic or actions. So here we're just doing the same logic, but maybe you have multiple different nodes that use the distance value to do something. So if the distance is too far, maybe we do an additional step to add certain pillars or something like that. So this is all giving you ideas on you doing different things. Or for example, if the distance is too small, maybe just delete everything and don't create any support structures. A couple other things that I want to show you here, some improvements you can do to the tool. I'm going to finish off the video. I'm just going to give you some ideas and some things that I've did to the tool to make it even better. So as you can see, first things we can maybe, of course, make the menu a bit better. We can do some offsets of, for example, how the models are stacked on top of each other just by having the position and just being able to offset. Of course, you can do a UV pass, which I've not really talked too much about, is adding UV. So there are a couple ways of doing this, and sometimes you can just enable UV in the sweep node. Sometimes you have to build a small UV node or network yourself to make sure that we have proper UVing. I might talk a bit about that in a later video. But one of the main things that I want to show you here is the placement of the props that can actually be done in a manual mode. So here I've actually made a manual mode, which is just a toggle. And I can input an add node, and this add node basically is points. Like there is nothing special about this. This is just the default add node, and I'm adding points. So for each point, I'm basically placing a model. So if I move this around, I can basically now control how a model specifically is placed in that area. So this allows me to control a lot how models are placed and how they should be placed. So if I'm not happy with this window, I can just grab this handle over here and just place it where I would like to see. Let's say if you want to probably align it, for example, here with the door, I can accurately align it with that. So the system like this is not that difficult to implement if you understand some of the structures that I've built. I'm basically swapping out the random generated points that we created with basically the add node points. So it's just a switch node, switching from which points to use. And this is really useful if you want to specifically build towards a look or type of building where we can just guide the tool itself. And there are many more things we can layer on top of this. This can be the beginning of a better and advanced tool to create buildings for a scene or project. And that was it for this tutorial. I'm going to round it up here. So thank you for watching. And again, thank you so much for all the subscribers to the channel. It's really great to see all the people liking the tutorials to help them on their Houdini journey and other game dev related topics. So thanks again for everyone here who subscribed. So if you're not subscribed yet, feel free. And the scene that I built here uses a couple more Houdini tools or other interesting Houdini generations. So I might be interested in making some videos on that as well. So let me know if you're interested in some of these things. I can cover some details on how this scene was made, if that is interesting to some of you. So that was it for this video. Thank you again, and see you on the next one.